fine. So we'll start UVA. So 5 UVA. Window side left and right. Simple control indicator that we are using. Let's you can see about how exactly you can with the help of control indicators. Some functions how we can introduce to it. Okay. So here I will go to my front panel. I'll go to my front panel. I right click on numeric. I'll check the numeric control. I'll put it as input A, input B. I'll check the numeric indicator. I'll give it again sex. Yes. So I check three controls over here. So two controls and one indicator. Check two controls and one indicator. The same thing I have it in the block diagram as well. Two controls, one indicator. So very fast we want next. I have which are belong to numeric data type. Yes. So what I do here is I go to my program, I right click on my block diagram. Yes. I right click on my block diagram. Do you see how exactly in the front panel I have a numeric boolean string? Here also I have numeric boolean string in other comparisons. Different functions I have here. So what I do is I go to numeric panel. I take some function over here. Take multiply. See, functions are not valid over here in your front panel. It won't support. I go to my block diagram. I keep here. So this is multiply icon. Yes, this is a multiply icon. So what I do here is I press Control H. I press Control H. So I get a context help window. Why? Because if I don't know about any particular icon, this context will tell me some information about the icon. So if it's full information about the icon, who will cursor onto it. So I move my cursor to this A. A is the double numeric. I'll go to multiply. Multiply is an icon which gives me returns the product of inputs. So to this icon, left side whatever I have put, right side whatever I have output. Am I clear? Yes. This will be useful for every icon you take. Let me tell you about it. Okay. So now I want to give wire connections. So how do I give wire connections? Okay. See here, don't do along with me. I'll tell you some small, simple, easy methods to do wires. See here. I go my mouse pointer to this particular terminal. You see my mouse pointer is changing from plus symbol to wire body. When I go near to this terminal, it is changing to a wire bundle. Also it is blinking, which means I am in the right place to take a wire. See, I click, I move. I'm not going to move. Just click and move. Now, when I look over here, when I go to this X, I don't know whether it is 16 or minus 3. Context will tell me where my wire is there. It is there at X. Okay. It is at Y. It is X into Y. Can I connect this wire to X into Y? No. Why? What is the reason? Because multiple output is also a source of data. Input is also a source of data. Two sources you cannot connect together. Two water flowing pipes you cannot connect together. One should flow, the other should take that input over it. Maybe here. Yes. So now what I do is I remove this wire, control Z, the wire will go into. Okay. So I'll click, I'll come here, I'll go to X. If you see here also it is blinking, which means I'm in the right place to drop a wire. So I click, wire got dropped. Now what I'll do is I'll check this wire. I'll just close this. I'll check this wire. I'll maximize my block diagram. I'll check this wire. Yes. I'll check this wire. See, I don't want this wire to move. See here, this wire is moving along with me. Wherever I take, this wire is moving. I don't want this wire to move with me. So what I do is, I put a cap. Now do you see? This wire is not moving. So no. So wherever I want to take a wire, I just click. I just click. However I want to take a wire, I just click. Yes, I mean, promise you planning. Not here mathematics. Small. Why are the educated coming around with this? No, I am getting my connected. So this is called feedback. Taking at the front, giving at the back. Feedback. What it is? Taking a long wire, roaming around the entire place, and giving over here. Yes. So I don't know how to wire it. So I have done it. So now look at here. I right click on this wire. I right click on this wire. So you see I have an option clean up wire. So once I give clean up wire, my wire will automatically clean up. I don't want to study a lot. How much you wire? Wiring. 2 kilometer you wire also wiring, no problem. Yes. Once you give clean up, it will automatically get clean up. Yes. That. So now again take from wire and keep over there to this terminal there. I have. Yes. Now, after doing all these things, what we will do, we will immediately arrange this. Take this wire, bring this there, pull this down, straight. We'll do all these things. Don't do this. Because if you see in this run button corner, there is an icon. Okay. This corner, there is an icon. What is this icon? Clear diagram. So if you see here, however I place it here, when I say clean up diagram, yes. So you don't want to do any of your arrangements. Everything is the question. Just read your logic. Keep your things what you want to give in out, function, output. Once you're done with that, just pick up your wires, clean up, clean up. So now you will come to know, okay, one function, two inputs, one output. I have it. Am I clear? Yes. First. Then we'll see about how to run this code, see that output, whether it is working or not, everything we'll see. Yes. That's it. Even next lesson. This is one of the there is no sufficient react language. Now there is no sufficient observable language. What is the installer? We got downloads in the movies. So you use a getting downloads. Convert your into this. Maybe this will be safe for if they can. The failure is this. If they have to choose this. What if they go to the next event and so they can just except just one for the What is how to see the output for this? Okay. So see here. See whatever you have done programming over in your block diagram. Now, if you want to see your output, you have to go to your front panel. You have to go to your front panel. In your front panel, you will see there is an arrow mark. Is there anybody getting this arrow mark broken? No, right? So now, both the inputs are 0. I don't know whether it is performing multiplication or addition. So I just give some values to it. I run here, so I get multiplied there. Yes, I run this continuously. Yes, I run this continuously. Why this value is not changing? See, 3 times are 15. So no, there are 15 times. You should keep on multiplying, you should update it. Run continuous. Why is it not happening? See here, this run continuous to run your entire program continuously. When the code is executed, you cannot modify your program. So the entire lab view is running. So what is happening here is every time you multiply 3 into 5, you get 50,000. You multiply once or you multiply 1 lakh times, 3 into 5 is 15. We have never made 15 into 5 again or 15 into 3 again. We didn't do that. 2 input, you multiply them. Multiply 1 time, multiply 10 times, multiply 10,000 times, nothing will change. Then what is the purpose of run continuous? Purpose of run continuous is used to tell you if there is a change in your code, it will update immediately there. See here, whenever there is a change in the input, your output is will get modified. Do you see? During runtime, if there is any changes, immediately it will reflect on your output because the code is executing. I will go and click on run continuous again to stop the program. I go and click on run continuous again to start the program. Same button to run continuous. Clicking on the same button to stop running continuous. So now what I do is I say here 5. I say here 2. Why there is no change in my program? Because I need to run it again. Code has been modified. Input has been modified. So the code has not executed. So to execute it, run again. Yes, run is once. Run continuously. Run the code continuously. Maybe here. Yes, very fast. Just 2 minutes. Then we move on to next. So now if you see here, the same thing, I'll go to my block diagram. On a right leg, I'll take a push button. I'll take one more push button. I'll take an LED here, all size 26. So now I have a million options. I have so now what I'm going to do is I'll go to my block diagram. Right click, boolean palette. Right click, boolean palette. I take an OR gate. I click over here. I connect input to here. One more input to here. Boolean. I take this. I keep here. So I write continuous. If any one input is high, I take my output high. So no. So during runtime, if any changes occurs, here get a result. Right here. Yes. Okay. So very fast. See here, we have a numeric function, we have Boolean functions. Let's say I will take a comparison here. I will take greater than or equal to. This is an OR gate. This is greater than or equal to. I press Ctrl H. I press Ctrl H. I choose here. You see here, some functions will have numbers, all inputs are in numbers. Some functions has all inputs are Boolean. But if you see, this function has few Boolean, few numbers. Numeric and Boolean both are there. Maybe you have some few way. One. Yes, you don't know where to connect what wires. So what I will do is very simple. I give you an option to get I can't see. See here. I right click on the icon. We have an option here. Create control. That's I right click. You create control. Why? Right click. Create. Should I click control or indicator? Because I want to see the output. I create indicator. Yes. Now after doing all these things, you know, everything got cleaned up? Yes or no? So far, not been too critical. Yes or no? Everything we are doing it in the block diagram itself. Now I go to the control, look at here. What happens? Do you see here? All the controls are aligned to the left. Indicator is on the right. X is over there on the right. You see here? So now what I do is, once after you get X, Y, X greater than or equal to Y. Size 36. Yes, I run this program continuously. 0 greater than or equal to 0. True. I don't know. Right. So now what I do is, I'll keep here 5. 0 is less, 1 is less, 2 is less, 3, 4 is less, 4.5 is less, 5.9 less, 99 less. 4.99 is not equal to 5. So no. So here, when it becomes 5, 5 equal to 5. I mean clear? So now for me, have I done anything different to this numeric and Boolean for this comparison? No. The function requires controls an indicator, yet only created it. I have only defined, I need a control here, I need an indicator here. What data type it belongs to? It automatically creates. Here guys, yes, so you can easily take, you can work. And let's say this basic functions. And we will log them now. Be fast. Don't go to front panel. We have to control one period indicator. But again, feature into that. Right click on your block diagram. Right click on your block diagram. Right click on your block diagram. Go to Express. Right click on your block diagram. Go to Express. In Express, do you find input? Yes. In input, do you find simulate signal? Choose simulate signal. Drop it over there. Choose simulate signal, drop it over there. So now this palette will give you or a dialog box to choose different kinds of signal. For example, if you see here, I choose square to change to square, triangle to triangle, sawtooth, sine. So when I increase frequency, the signal will change. When I change amplitude, it will vary there. Yes or no? Yes. So now in this, whatever I want, I can define my frequency. I'll say OK here. So now what will happen is this block will generate me a waveform. Yes, make it fast. So now, okay. So now what I do is I want to see this waveform. So I right click on site, create graph indicator. Whatever I want, I'll do it in my block diagram only. I'll not go to my panel. And so no. Okay. So I'll take a graph indicator. Now I'll go to my front panel. I get my graph indicator segment. Line width. I run this program. Do you all get waveform? Red points. Do you all get waveform? Yes. To run this waveform continuous. Stop. Stop running continuous. So now, how exactly we can run this continuous is, why we do want to run continuous is when we vary frequency, it should update there. When we vary amplitude, it should update there. So what I do is I right click on my front panel, numeric, slide, which is my amplitude. I'll take a knob, which is for frequency. So I have a graph, I have a frequency. So I click here 1000. Have you all done? Have you all got this? step, I go to my block diagram. I press Control H. Okay. Where exactly I can connect this amplified frequency to this icon? Guys, just look at my screen and tell me where I can connect it. Second and third. Okay. By mistake, if you connect frequency to phase, it will vary. Differently. So, it is very close by there. Okay, there are lot of things where we can do this. Okay, so what I suggest you is, do you see here? Do you see here? In this icon, below there is a double arrow. Below side there is a double arrow. Move your mouse pointer there. Your mouse pointer is changing to a double-headed arrow. Pull down. I will pull down for 2. You can pull down for maximum also, no problem. But just only keep 2 because I need 2 inputs, so I can only 2. Yes or no? Yes. So now what I do is I go there, I do left click on it. I do left click on it. It will show me what are the parameters available. What do I need? Amplitude, frequency. I choose amplitude. I choose frequency. Now I get amplitude frequency. Now if I press Ctrl H to this icon, what happened? Please don't do that. See here. What happened when I have expanded? When I have chosen amplitude frequency, what happened there? The amplitude which was lying there have come down. There is a lot of mistakes we could do. We are going to offset frequency we may come to face. But here, you cannot do that mistake because it is very clearly mentioned this terminal is for amplitude, this terminal is for frequency. So you can exactly connect to the respective terminals. So no. So I move my frequency to the frequency, amplitude to amplitude. Yes, amplitude to amplitude, frequency to frequency I have connected. Now I'll go to my print panel. I run continuous. I vary amplitude. I vary frequency. Signals will vary. Yes or no? Yes. But signal is not continuously running. Signal is not continuously running. How to run this continuously? First, we finish this. I'll tell you how to do that. Make it fast. I run my program once, so it is running. Run continuous also what is happening is our signal is continuously updating that 2 cycle. Every time 2 cycle it is posting on it. So we could not visualize the speed at which it posted. So now what we do it is we try to slow down the process. So we control the slow. So right click on your block diagram, go to express, right click on your block diagram, go to express. Do you have execution control? Do you have execution control? Right click express execution control. In execution control, do you have while loop with button? Select that. So now what I'm going to do is, do you see here? Now my mouse pointer I have changed it to uh, a square block type. Okay, a box type. So now what I'm going to do is, to this entire code, I'm going to enclose it. See here, I will tell you how to do it, or else it won't work. So what I do is, I just click and I expand. I'm still holding it. Okay, I still click and expand it. How much size I want, I expand and I leave. So what will happen here is, this block has ending. This block has entire code in it. Now, which portion wants to run? What I am doing is, it is running over here. Now, this is while loop. So this while loop, we are creating a condition. Stop. Whenever I click on stop, you should stop. Now, what is this I? This is loop iteration. What is this red color? This is a loop condition. See here. This is a loop condition. We will give while I equal to 0, I less than or equal to n, I plus plus, that I less than or equal to n condition you give, right? What condition is here? While condition. So for that I created a stop button. So if you can't stop, should stop. So then I is your while by iterations. So it will tell you how many number of times it is running. If you want to see, you can create an indicator. Am I clear? If you want to see, you can create indicator. So right click on this file, create indicator. So this is iterations. This is iterations. Everyone, you all got your code enclosed with it. Now, this is your while loop. What is the purpose of a loop? Run a particular set of code in a tree. Yes or no? Now, I go to my front panel. I have a stop button. Don't run continuous. I said, don't run continuous. Your stop button will not work. So, how many of you stop button is not working? That's what I'm saying. Don't run continuous. Your stop button will not work. See here. Okay, let's all you face some problems. Getting solution. Guys, see here. I run my program. Your signal went very fast. Yes or no? I run so I can stop. Do you see iterations? How much time it executed? I run this program. I stop this program for just 2-3 seconds. It ran for 1 lakh times. It runs very fast. In that, if you are using run continuous, I'll tell you. In this, if you use run continuous, if I say stop, what happens? It again kept on running there. So, what is the purpose of run continuous? What is the purpose of run continuous? Run continuous will run the entire logic speed. What is the purpose of loop? Run particular portion continuously. So you run one time, so this while loop will run multiple times. But when you do run continuous, what will happen is first time of lagging run, while loop will run for n number of times. You stop while loop. Again, log will say run again. So while loop will run. You stop, log will say run again. So it will keep on running. You can't stop it. So see here. In run continuous, how to stop it, I will tell you. Don't go and hit on that red color dot. Go and hit on that red color dot. See here. Click on the same run continuous button again. You are running continuous. First stop running continuous. You make your code run one time. Then hit on stop button. Your code will stop. Am I clear? Whenever you are using loops, no run continuous button. Am I clear? Whenever you are using loops, no continuous button. See, without using loops, at least the signal are moving, I can see. Now, after using loops, it was running very fast. I didn't even visualize how fast it is running. So, no. So, now what I will do it is running at a very faster rate and it will slow down. So, what I will do, I will add a time limit. I will go to my block diagram. I will go to my block diagram. Right click on your block diagram. Right click on your block diagram. Go to timing palette. Do you have a timing palette? In timing palette, do you find rate? Choose rate. I drop it inside while loop because I want to slow down the while loop only. So I keep it inside while loop. This is a icon, new icon. I press Ctrl H. What is the purpose of this? It will wait the specific number of milliseconds you provided. It will wait for the millisecond times you have given. So now what I'll do is, so here I write it, I constant, I keep input constant. So if I keep 1000, what will happen here is, my code will update for every 1 second. My while loop is running for every 1 second. You see, count also happening for every 1 second. Every update is happening for 1 second. Okay. So if I want to reduce that, you change this to 100 or 200. I run this program. So you see signal is moving. When I reduce it, when you vary it, you could see signal is moving up and down. So you see signal is updating. So yes. Fast. Okay. How many are getting there? How many are not there? Nobody is getting any error. Sampling rate frequency must be less than sampling frequency must be less than sampling rate must be less than or equal to frequency must be less than or equal to sampling rate by 2. What is sampling? We don't know. We have given option 1000, so you do. Yes. See here. Stop your program. Already your program got stopped when there is an error. Yes. Stop your program. Right click on this frequency. Right click on this frequency. Right click on this frequency. Do you have visible items? Yes. So visible item. Do you see digital display? Select digital display. Those who have got error, sampling rate error, your frequencies are greater than 500. Yes or no? Whoever have got error, your frequencies are greater than 500. See here. I run my program. I just tuned for 500 and above. You get this error. Frequency must be less than or equal to sampling rate by 2. I say stop. 500. You will not get error. 501. You will get error. See here. 501. You will get an error. What is this 500 and 501? Why? Can we generate 1 kilohertz signal? Can we generate 2 kilohertz signal? If I want to generate another kilohertz signal. See, this is very, very important. I'll go to my block diagram. I'll go to simulate signal. Double click on your simulate signal. Guys, double click on your simulate signal means on the icon, not on this. If you double click, it will select the name. Double click on your icon. Double click on your simulate signal. Do you see samples per second is 500? So we all have 1000. Yes, we all have 1000 there. That's the reason you are not allowed to generate only up to 500 hertz. If you want to increase, you have to increase your sampling. Then only you can go for higher number of frequencies. Or else you cannot go for higher number of frequencies. Try to understand. Yes. See here, let's see here, if you want to go for higher frequencies, you need to have a more number of samples. Then only you can plot higher frequencies, or else you cannot plot higher frequencies. It's very simple. It is very simple here. If you see in it, I have 1,000. Yes, I have 1,000. So when you keep 500, what do you see here? Triangle. So no, because for one waveform, for one cycle, you have 1,000. So frequency is 500. FM. Sampling rate is 1,000. Exactly half. Yes or no? For 500 hertz, 1,000 samples, which means for one cycle, you can take only 2 points. For every cycle, you will take only 2 points. So when you join these 2 points, 1, 2, 3, this is how it goes. That's what you are getting there. Am I clear? So now, for the same cycle, if I take 4 points, I can get somewhere extra here. So I'll get some multiple points there. Yes or no? Do you guys understand what I'm talking? So here, 500 hertz for 1,000 samples, I get triangle. But I'm generating sine waveform. I cannot plot waveform properly. In order to plot 1,000, I should get minimum 250. So now, see, signal is very less. You cannot plot. So I think 100. So now what do you see there? The waveform is not that clear. Yes or no? So if you look at here, I run my program. Sorry. I run my program. When I say 500, I run this point. I should get triangle waveform. So no. But why am I getting RAM? See, I should get a triangle waveform, right? But why am I getting RAM? Something as an increasing oscillation signal, because is there any compulsion or a guarantee always the maximum point and minimum point will be taken? What happens if this point and this point taken, it will be as I have frequency information but not amplitude. Yes or no? I have frequency information but not amplitude. So in order to take, I should go for more number of samples. So I will give 250. What happens here? I will get a 4 points there. Points type as this. See? 1, 2, 3, 4. In next cycle, 1, 2, 3, 4. So I can join, so I can build waveform. Yes or no? Fs greater than or equal to 4 Fm, I am getting triangle. Am I clear? So, if I keep here 125, what happens? Waveform is not that good. Yes? I'll keep here 60. Now do you see, for 60 hertz, I have 1000 samples. So taking more number of samples, I could be able to plot properly. But this value, for example, if this value is of visual item, digital display, I run this program, I say 1. Yes? Do you see here? Samples are enough for 60 to 1000. So samples are enough, so I got up to maximum 1. If I don't have sufficient samples, I will not able to. I will not able to plot the waveform. You understand now? I have to create the words. M plus greater than equal to 2 FM. That is the formula, right? M plus equal to 2 FM. But 300. F plus greater than equal to 2 FM. This is 1000. Greater than or equal to 2 into 300. So it is 600. 1000 greater than equal to. Why I am not getting sign there? Samples are less. So no proper amplitude. Frequency is okay. No proper amplitude. In order to put the proper amplitude, when I keep 100, 10 times higher, 100,000, 10 times higher, and still it's not 1, less than 1, and it is not a proper curve, flat. So no. Yes. So now what I do is I keep it lesser hertz. Do you see what I have? Do you see what I have? In this one cycle itself, I have so many data points. It's all nice. Do you understand? Yes. So samples are very, very important. Why? Because when you work with hardware, samples are important. If hardware is not four number of samples, then you cannot see those number of samples. I mean, here, sample. Okay. Now, I'll keep here. I have a doubt. I have a doubt. Is the signal of 1000 samples? Is this waveform what I am displaying is of 1000 samples? What different in your screen? See in my screen. Is this signal of 1000 samples? I can order in the counting rate. Is it of 1000 samples? What count man? Can't count. Yes. And very simple thing. When I get 20 hertz, how many seconds is that? 20 hertz. I give 10 hertz. Am I getting 10 cycles? Am I getting 10 cycles? Why? Because because do you see the time period is 0.1? It is not up to 1 second. It's not no. Yes, it is not up to 1 second. I will go to my block diagram. Double click on single signal. Do you see there is one more parameter which is there? There is one more parameter which is there. Number of samples. What is number of samples? Sampling rate is 1000. Number of samples are 100, which means my signal per second, it will take my signal per second, it will take 10 cycles of 1000 samples. Out of it, I will see only 100 samples. That's why you are seeing one cycle. Only 100 samples. If I say 200 sample, I will see 2 cycles. Do you understand? Yes. So if I you see here, I remove this, I'll take 200, I'll say okay here. I didn't change anything apart from the number of cycles. I'll go to my flash panel, I run this program. Yes. What happened there? From 0.1 it have gone to 0.2. Yes or no? So yes, now I have 200 points. So now if I want to see the entire thing, I'll keep 1000. All values I want to see. Now I'll go here. These are the things I have, all values I have. Understand? Let's stop. Do I have 10 cycles? Do I have 10 cycles? Yes. 10 cycles we have. 1000 samples I have. Yes. For one cycle of 100 samples I get there. Now, if I change this to 1 hertz, see, I have all 1000 samples here. 1 second, 1 cycle is 1 hertz. Number of cycles per second is frequency, right? 1 hertz, 1 second. If you see here, how many data points I have? These many data points I have. See, if I take how good, if I am taking 1000 points, how good I have waveform. The same for 1 hertz. If I take number of samples, then if I take number of samples as 10, if I run that, do you see where I have these points? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The next cycle will come. So I'll continue from there. Am I clear? So if I take 2 cycle, this is how I get. Samples are less. So you cannot plot frequency proper. The same principle applied to your hardware. Tomorrow if you are acquiring signal from a hardware, if your hardware is taking per second 5 samples, you can't plot a signal. Provided, provided, if your signal frequency is 1 hertz, okay. If your signal frequency is 100 hertz, you are picking only 5 points of that 100 hertz moving. So always you have to be 10 times faster than your signal, then only you can pick data. Very simple man. When we throw you a ball at your speed, if you want to catch that ball, how fast you have to be? And we throwing you a ball at you at X speed. I want you to catch. What is the minimum speed that you have to react? F is greater than or equal to 12. I put it at 1 kilometer, you should respond at 2 kilometer. So that at least you can catch. Why you cannot respond with the same 1 kilometer? Because the ball that travels, you also open, you both travel at the same time. You cannot catch them. So no. If I want to pick more number of balls, if you are running at 100 times faster, how many balls you can catch? 100 balls per second you can use. So no. So the same number of elements will be applicable for there also. so that you can pick more number of samples there. So if I want to acquire more number of samples, I can push my sampling rate as more there. So now I'll go to my block diagram. Samples 10,000. Out of 10,000, I'm seeing only 10. If I see 1,000 values over there, now what I do is I run this program. So you see here how good I have my signal is. So much good of signal I have over there. Yes, point style I remove. So proper, pure waveforms I have over here. Do you see over here the waveforms curve, higher number of samples? Yes. So now when I run here, I can go up to 1,000 also. Nothing will happen. Because I have kept my sampling rate as 10,000. Here it is only 1,000. 10 times higher. So obviously I can plot waveform properly. Yes. Make it fast. Just try to understand all this. I just save this as a simulate signal. Yes, simulate signal. Make it fast. far, whatever you have done is, so far, whatever you have done is, you have done something else. You have done something else, generating different frequencies of the bell. If you want to listen to the signal, yes, if you want to listen to the signal, what are we supposed to do? Here, new here, file, new here, go to block diagram. Right click on your block diagram. Right click on your block diagram. Go to express, input, similar signal. Yes, express input similar signal. Done. Yes. Now our signals may go beyond some range. So to have more number of samples, you can add 10 here, 10,000 samples. Keep 10,000 samples. I'll say okay here. Now I may increase amplitude and frequency variation. I'll go to my front panel, right click, slide, amplitude. I'll take frequency here. So I connect this to frequency. I'll connect this amplitude to amplitude. I create a graph indicator to this. I create a graph indicator to this. Have you all done this part? Have you all done this part? Similarly, done? Have you all done this? Yes. So now what we do is, now now we want to listen to the sound. Yes or no? Now we want to listen to the sound. I right click, go to express. Now what we have done is signal input we have created. Now something has to go out of my device. Output. So go to output. Go to output. Do you have play waveform? Choose play waveform. I drop over here. So now if you see in it, for me, This TV is connected. So it is showing TV display. Okay, for you, your laptop speaker should come. If you have connected to earphone, it will show that earphone. I wanted to find out whether the speaker is working or not. I'll go and hit on test device. Working on. Yes, working for everyone. Wait. Still wait for second. Yes, don't end up with fear on me. I'll say okay here. I connect to this sine waveform. I connect to this sine waveform over here. Okay? Now, this 4 has to run continuous for me because I want to vary frequency during runtime. So what I will do, right click on your block diagram, go to express, right click on your block diagram, go to express, execution control, right click, express, execution control, while loop with the button. Choose while loop with the button, enclose the entire portion with that, enclose the entire portion with that. We all know it will run at a very faster rate. So we'll add it directly. Right click, timing, wait, create, constant, 100. Yes, create constant, 100. So I have made this time delay over here. I put everything there. Have you all done this? After this, there is one important step is there. After this, there is one important step is there. Right? Have you all completed? Now, see here. Go to your front panel. Go to your front panel. In your front panel, see here. In your front panel, now what I'll do it is, now what I'll do it is, guys, important disclaimer. I will tell you what it is. Very important disclaimer. This is going to be a real hardware input. Okay. So if you are generating frequencies, definitely that particular is going to be come out of your system. Second one is most dangerous part is your amplitude. If you are keeping an amplitude to 10, literally 10 volts will come out of your PC. Okay. So you should not keep 10 volts out of your PC because its speakers are very feeble. Okay. So keep maximum amplitude as 2. Maximum amplitude as 2. Why I am giving provision for 0 to 2 is at least when you vary it, you can feel there is a change in the amplitude intensity level of the signal. Okay. And important disclaimer is Manimaran or lab B is not responsible for any signals. Okay, because I told very clearly above 2 volt I am not responsible. Okay. So now what will happen here is when I run this program, 0 hertz, when I vary it, so you can go for any frequency you want to go, you can come down. Okay. And I have kept up to how much thousand? Something rate 10,000. So maximum frequency you can go up to 5,000. So I change this to 5,000. So now when I run this program, see here, for different ranges you get different sounds. Yes. So you get very different sounds or you can listen more. If you have a time delay of 1 second, so every 1 second your laptop will repeat itself. Yes. So it is apply everywhere. So what will happen is, if you apply a filter over there, only between the filter only you will get the actual sound. For others, sound. Because on signal will get attenuated. Yes, on the signal will get attenuated. So what I'm going to do is, we have a original. So now we have original signal, we have to play the waveform. Now in between I am going to apply a filter to restrict particular frequencies. So no. So what I do is I delete this wire. What I do here is I right click on my block diagram. I right click on my block diagram, go to express. We got input, we got output. Yes? In between, if you want to do some changes, you will go to signal analysis. And in signal analysis, you see filter there. I choose filter. In filter, I keep here. So now what I'm going to do is, I'm going to keep a band pass filter. I'm going to keep a band pass filter. I'm going to allow only one particular frequency. I'm going to allow one particular frequency. What? 1000 to 2000. Apart from any frequency sound, not allowed. So no. Apart from any frequency signals, you should not be allowed. So I'm going to keep here higher cutoff frequency is 2000, lower cutoff frequency is 1000. Do you understand? Lower cutoff frequency is 1000, higher cutoff frequency is 2000. So when I say OK here, this is input signal, this is filter signal. So now what happens here is, I will get the sound, actual that waveform sound only between 1000 to 2000. Beyond this range, I will not get any sound. So no, that's how it's supposed to work. So now if you see here, I run my program. I'll go to my front panel. So I get low amplitude sounds. Yes or no? It's only that bass sounds what I get. Here also I'm getting only low. But actual sounds are having only stage. That noise elements along with the sound I'm getting only slight. Am I clear? It is understand. Only with that range I'm getting. The other ranges my signal have come down. Only for that particular range it will work. Other ranges you get only the dot sounds. Because go to almost 0 level. So no. Yes, only in that frequency you get also. Other things what go there. So beyond a particular range you will not get sound. So no. If it working in that way, for one range it will work, for other ranges it won't work. For your hardware, you need to install many drivers. And here, so please start with any drivers installed and multiple drivers installed. Yes. So we have 10 set of devices. One is one hardware application in the other one. And So it's starting.